Okay, so this is a rotational dynamics problem. So we just did rotational kinematics. This is rotational dynamics, where net torque equals I alpha. So Newton's second law for rotational motion. Yeah, and this is from this point we're trying to solve for. So the equation's set up for torque. So that's what we're trying to solve for here. So the I will be 1/2 m/r squared. So mass is 0.2 kgs, or is 10 centimeters, so that's 0.1 meters. So that's the I and the alpha. So the alpha is delta omega over delta t. So it goes from, so this will be just equivalent to omega f minus omega I over delta t, so omega I is 0. You want this in rads per second squared though. So you want 1800 times, so 1800 revolutions times 2 pi radians divided by 60. So there's 60 seconds in a minute, 2 pi radians in every revolution. That all divided by 4 gives me 47 rads per second squared. So I would have 1/2 0.2 kgs times 0.1 meters all to be squared times 47 rads per second squared gives me a torque of 0.047 Newton meters. So A. Any questions? Alpha? So the question is, does alpha always have to be in rads per second squared? Yes, if you want to find torque in the correct units.
If you're starting at some amount of revolutions per second or something, I don't know, if you want to find out, you're using it not in this equation, but a different equation.
So the unit of alpha, this is the SI unit, rads per second squared. So it could be in revs per second squared, it could be in revs per minute squared, rev per hour squared, radians per hour squared. All depends. So I always encourage to go to SI units and do the conversion at the end of the problem, because if you have a non-SI unit, then everything has to be sort of consistent. So it's much easier, I think, to go to SI units and at the end make a conversion. That's what I encourage. Yeah, so the question is, even if the answer choices are not in SI units, if you're very comfortable, then of course you can make a shortcut and make sure that you can work with the units inside the equation such that the answer is the same as the units of the units as the choices, but you need to be obviously very careful.
Shouldn't the unit of torque be Newton times meter?
You're totally correct. Sorry. Yes. So ignore the force times the distance. Yeah, Newton meters, correct. I think I got confused with K. Yep.
So why do you use that torque equation and not just the Barber network?
You don't know net torque will be the F times, in a sense, the R perp, but you don't have F. And there's no way to solve it in this problem. So the I disk should immediately trigger I alpha. That this is not an F perp or perp question. This is a rotational dynamics problem where I want torque from I alpha, not from the F dot R. Or F cross R. That's the next question. Okay.